All right, hello everyone, and welcome to the first ever Cloud Engineering Summit. Really excited to have you here. We've got a great lineup of speakers, some awesome content throughout the day. Before diving into that, I want to take a brief moment to thank all the great sponsors that have made today possible. GitLab, JFrog, JetStack, Chef, AWS, and NS1. Of course, presented by Pulumi, the company I work for, but really appreciate the support for cloud engineering overall. So with that, I wanted to spend just a minute introducing ourselves, getting to know each other before we talk about cloud engineering, why we're excited about this. And to kick it off, I'd like to introduce Adam.
Hi. Yeah, I'm Adam Jacob. I'm the CEO of a company called The System Initiative, which has a website that says The System Initiative with a little blinky cursor on it. And I was formerly the CTO and a co-founder of a company called Chef, which did infrastructure automation. And I'm super stoked to be here. Hi, everybody.
Yeah, and I'm super stoked to be here also. My name's Joe, founder and CEO of a company, Pulumi, that builds an infrastructure as code platform using your favorite languages for infrastructure as code. And my background, leading up to cloud engineering is interesting. I worked at developer platforms at Microsoft for many, many years. Really lived and breathed developer productivity day in and day out, and really get excited about modern cloud architectures. And that brought me to the world of infrastructure and DevOps and all the great work that's come before us, and really excited about the future of cloud engineering, and to tell you a little bit about that story today. And so to kick off the story, I'll start with maybe a controversial position, which is, the cloud really is the world's biggest supercomputer. The cloud is sort of infinite in scale, both in compute and storage, worldwide, distributed. Think of really modern architectures are really moving in the direction of distributed applications. And what that means, if you believe that premise, is, and especially you look at today, the fact that we're not writing client-server applications like we did 20 years ago, 15, 10, even 5 years ago. All software is cloud software. What that means is software is using the cloud for those compute and storage capabilities, but increasingly managed services that add value, and in that we don't have to go kind of build all these things by hand. We can leverage these building blocks in the cloud and leverage them in new ways.
And I think it's really important to highlight all here. There's this idea of cloud native software, which has been a pretty big idea, a pretty big concept here in the last couple of years. And it's drawing this distinction between legacy software, which is usually what we mean when we say like the stuff that runs all the things that matter most in the world. That's legacy software. And then cloud software, which is like the new stuff that's been written, since the cloud has been born. And I think the reality is we're now at a place where there isn't any piece of software, regardless of how it's deployed or when it was written, that doesn't have some cloud impact, right? There's some component somewhere probably in what makes it work that lives in the cloud. And ultimately, we've sort of already reached the point where every piece of software, regardless of when it was written or how it's deployed, likely interacts with the cloud in some way, and therefore all of it really is cloud software.
Absolutely. And why is that important? Well, it's important because it changes the way we think about software architecture. It also changes the way we think about our teams and how we work with one another. I think of all developers are cloud developers. All software is cloud software, and developers are the ones, authoring the applications and designing and implementing them. Then that really means all developers are cloud developers, and really need to think about the cloud in a first-class way. It's not something you think about after you've designed and implemented, but it's really something you think about at every stage of the life cycle.
Yeah, fully. And if you think about all developers today, like if there's a part of you that was like, not everyone's a cloud developer, like if the cloud's a supercomputer, there isn't a software developer alive who doesn't think about the computer that their software is going to run on. That's the whole point of writing software, right?
Absolutely. And I think it's exciting too. Even if you're not directly touching the cloud, maybe you're writing an application that gets packaged up into a Docker container and run inside of a Kubernetes cluster. Well, you can kind of ignore that point, but it's only a matter of time before you need to be aware of that. What happens when you need to debug your application? What happens when you need to do logging and monitoring and understand the performance of your application? All of that means that you will become increasingly aware of the cloud hosting environment. It's not a black box that you can kind of ignore. Related to that is really, okay, think about infrastructure teams. They're really the ones enabling this to happen. I mentioned the Docker and the Kubernetes example. The infrastructure teams are the ones providing the infrastructure platforms that developers are going to use to build and deploy their applications. And many infrastructure teams, really want to enable this level of innovation within the organization. All of the applications are going to be cloud applications. They're all going to require infrastructure, and the infrastructure team really holds the keys to unlocking all of that application development and software delivery within the team. And so that brings us to really the three themes that we're going to talk about today, which is architectures, workflows, and teams. I think architectures are fundamentally changing as we move to these more distributed architectures. The workflows are really how we take those architectures and operationalize them. How do we make sure they're secure? How do we test them and verify them? How do we ship them continuously? How do we debug them after something might go wrong? The teams component, fundamentally is different than it used to be. It used to be okay, that developers didn't really think about the cloud, and the infrastructure team did the heavy lifting there. We're really thinking about teams where cloud engineering teams are taking the best of what everybody has to offer and making sure that we can collaborate and move fast. We'll talk a little bit about the future in today's talk as well. So I want to spend just a moment motivating, where might we be going before we get into a little bit of the details of kind of where we are today and how we got here. If you think about the cloud as the world's biggest supercomputer, it begs some obvious questions. Every computer has an operating system. What is the operating system of the cloud? Where is it? Do we have one today? And I think we'll see throughout this that we have a lot of the fundamental building blocks for an operating system, but we don't yet have a true operating system.
We both need one and do not have one. I think the most common thing I hear now when people talk about there being an operating system for the cloud, it's usually people talking about Kubernetes as the operating system for the cloud. But I think it's probably not. It's probably easier to think of it as as some combination of, is it like a scheduler, is it a kernel, is it what is it exactly that it's doing? But when we think about operating systems, they're so much bigger than just taking my application and shoving it somewhere, right? Everybody who's watching this right now is running an operating system, and you have this window into everything you do that the operating system provides. That's the user experience, it's the developer experience, it's the way the tools are shaped. All of those things are part of the operating system. It's not just running an application. And I think we really haven't seen a huge change in the idea that if we have the world's biggest supercomputer, what's the user interface to that supercomputer supposed to be? What's the human experience of using that computer? We've really just extended what the previous experiences were out into being more available in the cloud, which is great, but it's really just a foundation.
Absolutely. And related to UX, which is a great, important point, the UX for developers and infrastructure teams interacting with the supercomputer is also still, the jury's still out on kind of where that's going to land as well. Certainly YAML is our current programming model interface, and I think we all dream of something, a bit richer than that allows us to build bigger things out of smaller things, and really all the things we know and love about programming models for all these other operating systems. In the future, we will have a similar thing for the cloud supercomputer.
Man, I hope so, because I think if the model is just YAML, I'm maybe out. I might go back and decide that the cloud wasn't for me.
Absolutely. And then finally, the application model. You think of kind of relating to the notion of operating system and what is an operating system. One of the things an operating system provides is an application model. How do I install applications? How do I version those applications? How do I sign them to make sure they're secure? How do I remove them when I want to get rid of them? And today, Docker gives us a nice building block for individual containers, which is great. And there are certainly, efforts to go beyond that, like CNAB and Helm really kind of give us a little bit more of that installation model. But it's really a far cry from, you think of the iOS App Store.
And this goes to speak to almost every piece of that architecture, workflow, and team thing that we were talking about just a second ago. Without an application model, what it means is that the only thing we can do to drive this supercomputer is work way down low, right? All we can really do is kind of twist the knobs low level in this system, which then result in something we could run. And I think when we talk about application models, it becomes a little more top down, right? It becomes a little more like, yeah, if you define what this application is and what it needs to run on this giant supercomputer, the giant supercomputer should figure out what that's going to do and where it lives and how it's going to run. And like those layers need to be more semantically clear than they are now.
And so that kind of leads you to the conclusion. The cloud kind of broke things, right? We knew what the world looked like in this simple client server model, and as we moved to this more distributed model of the cloud as a supercomputer, we're still trying to figure things out. And as we were talking about this keynote, Adam and I were brainstorming. We really realized that the cloud kind of broke architectures, workflows, and teams, and that we're now rebuilding.
Absolutely. I think, when you think about the early days of the internet, so, I'm 42, so and the first time I used the internet was pretty early on in the internet's life because I loved bulletin boards. I ran my first bulletin board when I was 8 years old. And when the internet started, there wasn't like a book you could read or like a best practice to understand like how you were going to manage this internet thing you were doing, right? All you really had were the books that were written about how to run Unix systems in corporations or in university computer labs, right? It was the Dragon book, or it was the Aileen Frisch's Armadillo book, and those were what you did, and that was the model we all tried to copy when we were running services for the internet, and it just didn't work, and we had to figure out a whole new way of running things, and that was sort of how the 1.0 of the internet worked. But then the cloud comes along, that entire model fundamentally shifted yet again. And its first pass was really just to take what we had learned in the first part of the internet and automate it some more so that we could hide it behind APIs. And now we have to go beyond that even and say, okay, now that these things have been we've sort of dealt with them a little, we've agglomerated, is that a word? I think it is now, what it means to do this kind of work. What can we build from here, knowing that this is the status quo, that it's here to stay, and that this shape of the universe is what it is?
Absolutely, and I think one of the fundamental things that happened along the way that Adam just mentioned was infrastructure became software, became programmable. Suddenly there was an API, and this is why all is not lost. We've got a lot of the foundational pieces we need to rebuild something amazing and way better than what we had before. We're still early days, but this is where cloud engineering comes into the picture. And I think, it's interesting to look back over the last 10 years as the cloud was sort of incrementally breaking things, we're having to react in real time to that and build tools and build automation. And we did a great job. And I think, the future of cloud engineering could not be possible were it not for DevOps, the last 10 years or so of really practicing DevOps.
Yeah, definitely. I mean, look, DevOps, I feel like I was lucky enough to be present for the whole evolution of DevOps from its very beginnings to now. And I think it was this really necessary response to these new capabilities that we had, that the way that we worked together, the way that we managed things, the architectures we supported, just like now, 10 years ago, everything was fundamentally broken and we were trying to figure out how we were going to deal with it. And it started from this place of collaboration and this place of bringing engineers and operations people closer together so that we understood that it required both of those things in order for the system to really come alive. And it required sort of a holistic understanding of those disciplines in order to adapt to this new world. I think where DevOps landed over time was a little more opsy than Devi. And one way you know is that, when you hire someone to do operations work, you hire a DevOps engineer. And, there were arguments for a long time about whether that was a good or bad idea, but it doesn't matter now because it's definitely what it means to be an operations person now. It means you're a DevOps engineer. And if you were to ask a regular software developer who builds applications, if they're DevOps engineers, their answer would be no, right? Because they're still software engineers. And I think where we move from DevOps into cloud engineering, I think cloud engineering is a superset of what we learned from DevOps. It's going to take all those lessons about how we needed to work together, all those lessons about the various shape of the organizations and the shapes of the teams, and that need for a holistic understanding of the stack, and then push it into this new paradigm that says, okay, but now we need to build systems that were designed for this world instead of just designed to cope with the transition from the world we were in to the one we have now.
Totally. And so that leads to cloud engineering. What is cloud engineering? And really, it's exactly what Adam said, which is taking all those lessons learned from DevOps, really making sure that application developers are leveraging the cloud in a first-class way. So infusing the cloud more into application development, and especially with modern architectures and services, this is almost an absolute requirement. But it's exciting as well. And the second thing is applying engineering practices to infrastructure. We see that increasingly as infrastructure becomes software, it becomes programmable, we're able to actually apply engineering practices like testing, like refactoring, like security enforcement, continuous delivery, agile, a whole lot of things that we know and love about application development can now apply actually to infrastructure as well. And then the final thing is unlocking collaboration. And this is really where I think DevOps has done an amazing job of really creating a collaborative environment where everybody can come to the table with their own skill sets, contribute them, and move faster and deliver amazing capabilities in the software that we're delivering. And to me, this is just a broadening of that approach to developing cloud software, which is to say the entire organization becomes the cloud engineering organization, including app dev, including DevOps, including infrastructure, including security engineering as well.
Absolutely. And the thing that most fires me up about this idea is that it's focused not so much on how do we cope with the change. Instead, it's saying, look, we know how to cope with the change now. Like, we understand what the pieces are. We're coping just fine. This is about what can we build? Like, how could it be better? What could be different about the way we interact? How could we really move the state of the art forward in a way that, you can't do when you're just trying to stay afloat, when you're just trying to deal with how much has changed. It's really hard to think about what's the new way that we could infuse the cloud into application development, right? What's it mean if the cloud is a giant supercomputer that it be fused into application development? I think it means that the whole paradigm could shift. It could change the way IDEs work. It could change the way application development work. If you think about that applying to engineering practices, if we say engineering practices apply to infrastructure, can we have the same kind of IDE experience that we get when we write code only in infrastructure? Could we see it across all the different components that exist in the cloud? Like, there's so much potential for the future that cloud engineering really can be this forward-looking idea that says, how do we become better than what we are? Because now we're standing at a new baseline.
And the most exciting thing of all is, we're starting to see a lot of this emerge, and so today what we'll do is we'll walk through, the architectures, the workflows, and the teams that we see comprising modern cloud engineering as it is today. And then we'll spend a little bit of time at the end just kind of talking about, what does the future entail. But if you're, excited by this vision, you can start practicing and take some very concrete steps down this road starting today. When I look at infrastructure, I'll admit, my background was more on the developer side, for over a decade at Microsoft and even before that. And when I got excited about cloud computing, with microservices and Docker and serverless, and I actually thought infrastructure was boring. I thought it was boring when I came to the space. And what I quickly realized is infrastructure is actually essential. Infrastructure is the building block of the cloud. Every one of AWS's 200 services, or Azure's 100 something services, or Google Cloud, or and SaaS providers too, Datadog, New Relic, etc. These are all building blocks that we can assemble in unique ways to build new capabilities in the software. I think this is why it's exciting for both infrastructure teams and for application developers. I think of infrastructure building blocks coming in many different flavors. Obviously infrastructure is the essential compute, networking, and storage layers that power our applications. We see AI and ML services that we can use kind of right off the shelf, right? I think AI and ML are two of the most compute and storage intensive services that you can imagine. And the fact that we can just leverage this huge supercomputer to run them and integrate them into our applications means things like, Lyft and Airbnb and all these companies that are really leveraging the cloud is much easier to innovate and build those sorts of applications today and scale them globally as our workloads scale as well. And what that means is, infrastructure used to be a tax. We used to think of IT as a cost center that was kind of a necessary evil to run our applications, but that's no longer true. In fact, the exciting thing about this this transition is that infrastructure becomes a competitive advantage where you can actually use cloud infrastructure to transform entire business models. I mentioned a few just now. One of my favorite stories is sort of the Zoom CEO who when the pandemic started, COVID started, they saw 10 to 20x usage almost overnight. And because they had architected their application to use the cloud, they were able to scale and meet the demand. And of course, Zoom is an essential part of our lives because of that. And that was all about cloud infrastructure. If the cloud hadn't been there, if we were, even 5 to 10 years ago, that simply wouldn't have been possible.
And it's a great example of the evolution from having disruptive technology like EC2 to fully embracing that technology and then using it as a building block of a foundational piece of the entire application's design. One of the most informative things that happened before I started Chef was I had a consulting company and I was working with some friends who ran a company called Zoosk, which was one of the first Facebook applications. They were a dating app. And when Facebook launched applications, Zoosk was the very first thing you could do that allowed you to do dating over Facebook. And it blew all the way up. It went completely insane. And Zoosk went crazy. iLike was another example where same kind of era, iLike was about music sharing, and you could share music on Facebook, and it was a huge deal. And, the iLike guys, they were literally going around to everyone they knew and asking them if they had spare servers that they could rack to deal with capacity, right? And this wasn't that long ago, right? And when you compare the experience that Zoosk had, which was just a little after iLike, where they could use EC2, they could scale elastically, they could do those things, like they were using that cloud environment as a competitive advantage and a competitive weapon in a way that even within the span of 6 or 8 months difference, iLike couldn't do. And now you get to something like Zoom, where it's a commonplace piece of core infrastructure. When we think about this as a massive supercomputer, I think that's one of the reasons that it's the right lens, because that transition over time really is pushing you toward this idea that, no, we designed it to run on this planet scale computer, and it does.
Yeah. And, it's definitely not easy to accomplish that. But I think, really going in with the mindset that cloud infrastructure is a superpower, and that, those who figure out how to harness it to build these new software capabilities really are the ones innovating and creating new experiences. And really it is a testament to, hey, the power of all those building blocks available to us at our fingertips if we can only figure out how to harness them. And so that, I think, one of the challenges is how to harness that, but that's really where cloud engineering comes in, which is to say, the way to really leverage that is to let developers, use cloud capabilities in a first-class way, have infrastructure teams kind of empowering the whole organization. And so cloud engineering really is all about, accomplishing that outcome. And so as part of this transition, we're really reshaping the way our applications work. You look back to, when Adam was mentioning the early internet days where, client server had just become a thing. We had a client and a server. There were two moving pieces, and then we started breaking apart the back-end services into, N-tier architectures, and then we lifted and shifted virtual machines in the cloud. These architectures were pretty simple, mostly monolithic. There were a few moving pieces, but not many, and very static. And so these days we really think of, hey, what we're really building are distributed systems. They're complex, they're distributed, so there's RPC, mechanisms, it's all asynchronous. We need to think about things like service meshes and discoverability. They're dynamic, and so oftentimes we're not only provisioning new capacity on a much faster rate, but maybe in real time in response to demand with some of those serverless architectures. And this just requires us to think in fundamentally new ways about the architecture of these applications. If we have these dynamic, elastic, distributed architectures, how do we actually build them? How do we test them? How do we deploy them? How do we manage them within our teams? And that's what we're calling workflows. And, we've been on this infrastructure as code journey for quite some time now. And so one way of looking at that is, we've kind of treated infrastructure as text, but not software. And I think infrastructure as software is an exciting next quantum leap in how we do infrastructure as code, which is to really bring those software engineering techniques to the way we manage infrastructure. That includes architecture so that we've got real patterns and best practices. We're not copy and pasting text all over the place. We actually have a real sharing and reuse package model. We can develop new infrastructure, productively as we can develop applications. We can test that infrastructure using all of the tried and true techniques that we've learned over the many years of dealing with software. And we can secure the infrastructure using those tried and true techniques as well.
I think this idea of infrastructure as text to infrastructure software, like, it's so compelling. I've spent so much of my life doing infrastructure as code and doing infrastructure as text from, the very beginning of my systems administrator career, which I still kind of feel like a systems administrator, all the way till now. And this idea that it has to evolve from just text to software, like, a big piece of that is that right now you don't actually interact with your infrastructure as code systems at all once they're running, right? You write this code, then you run the software, then it reaches out and makes whatever changes it's going to make to the world at large, and then it's finished, right? And maybe you're running it in a loop so that you're doing drift detection and you can reconcile state, but like ultimately, they're not software that runs like an application runs in its own right. You can't interact with it interactively. You couldn't ask it what its state is, because it doesn't really have one, because its only real job is to let you describe what you desire and then make it so, hopefully. Sure, it can like check in every now and again, and Ansible, you can like decide to like do something right now, but ultimately it's not really the same as when you think about when we write software. We don't think only about the code that went into writing the artifact. We think about how we interact with the artifact once it's running. We think about the API that we can interact with. We think about all the different pieces that went into that system. And I think this is just a really powerful and important frame for thinking about how cloud engineering can be different than what we got with infrastructure as code and what we got with DevOps. Like, there is a place we can go that I think is really exciting and unique and special, that lives around this idea that the infrastructure itself is a programmable piece of the puzzle, and that we need to treat it like one, not only in the development lifecycle, but also in the runtime lifecycle and across its entire life.
Yeah, and once you get into that frame of thinking, a lot of things pop. So one is that the inner loop that we're used to, that this idea that you do all your application development within your editor, and then magic happens and suddenly it's running in the cloud, and it's not something you had to think about in your editor. That's just not the world we live in anymore. And so one of the critical pieces of the workflow that the cloud really did break, in a sense, is the IDE experience. You think of, how do I go from writing code to getting it running in production, or even a test environment in the cloud? And oftentimes there's manual steps. You have to step out of your editor. You have to go maybe into the cloud console, point and click. Maybe what you're testing locally isn't quite the same as what's going to run, once you deploy it to the cloud. And you're often hopping around, going into a terminal, running some commands. The experience is very disconnected today. And so the inner loop of how you work has become not so inner.
Absolutely. I'm so stoked about the idea that we could solve this problem. Like, how do you, when you think about what's possible in software, I saw a really cool demo of some ORM code that was written in TypeScript, that when you define the query you want to run, depending on the way you deploy it, it either runs through a Lambda that then does a proxy back to the actual data store, or it talks directly to the data store that's running on your laptop, and the developer doesn't have to know the difference. It just happens magically by the compiler at deploy time. And like, that sort of thing is so interesting. And when you think about those possibilities, however you think about it, like, somebody out there is like, that's too much magic. But like, forget about the details for a second and just think about what could be possible when we think about, is even an editor is an IDE as we understood it the right environment? Maybe we need different kinds of tools that run alongside the IDE. Maybe the way that we think about how the system is built could be fundamentally, foundationally different than it is right now. But in order to get to that future, you have to think holistically about what's possible. If you're focused in on how the world's been constructed so far, then it necessarily constrains you to thinking in terms of terminal windows and code editors, as opposed to thinking about it in terms of workflow and collaboration, and how do we get those reusable patterns and practices. We know that there's a way to work together to create these infrastructures because we're doing it all the time. But could we build better experiences that really take advantage of all of this capability to make that inner loop inner again? So cool.
Yes, no, I'm super excited. I have to laugh when you say, is it too magic? Is it not? It's funny because IDEs really are magic.
Because they're complete magic. Type systems are complete magic, right? Like everything about it's magic.
Everything about an IDE is magic. I worked on debugging and edit and continue and refactoring support and setting breakpoints, for Visual Studio many years ago. And if you knew how all those things work, like they were just crazy. They really are magic.
If you think about that, what's the equivalent of the Chrome debugger for your cloud infrastructure? That's infrastructure as software, right? That's infrastructure as software. Because now we're talking about like, oh yeah, could I set a breakpoint that happens right before I launch the EC2 instance or right after, or that tells me whether the AMI was right or wrong? Like there's so much potential there, but we haven't even begun to tap it.
Absolutely. And if we're lucky, somebody watching this will go build that because we all need that.
Oh, please do.
And related to that, testing is something we do see, once you start applying software engineering techniques to your infrastructure, it unlocks a lot of that workflow. So despite everything we said about editors, at least you can edit your infrastructure as code in the editor and get refactoring and all these great go to definition, things that we know and love. And you can also test. So that's one great thing that we have figured out how to do, through some of the great work that Chef has done and some of the work that we've done with Terraform and with Pulumi, where you can actually test your infrastructure in addition to your application code. And the nice thing about that is, whether you're testing applications or testing infrastructure, this is a critical part of the software release life cycle. And it really spans a lot of different possibilities. And so when somebody comes and asks me, hey, how do I test my infrastructure? The answer is actually quite difficult because there's many different testing techniques. And some of those include unit testing. That's just for basic code correctness. Did this function do the right thing given a certain set of inputs? Did it produce the right output? There's integration testing for larger system integration. Does the composition of all of those functions do the right thing? But more interestingly, these days we're seeing, especially for cloud architectures, new workflows where people are actually doing ephemeral environment testing. And how that typically works is maybe in a pull request within your GitHub workflow where you're collaborating with your team and doing code reviews. Maybe part of the pre-merge validation is to spin up an entire environment of your cloud application, run a battery of tests and make sure it works, and then tear it back down. And treating infrastructure as software actually allows you to do this. And it's game changing. It really changes the way you think about confidently shipping all the time new innovation, new features out to your production environment. There's also advanced testing. I think one of the cool things I've seen is, people doing chaos testing where they'll actually simulate an outage for an entire region to make sure, maybe the Kubernetes cluster failover works correctly, or even within a region, maybe a single availability zone goes out and maybe there's some fuzz testing to randomize the environment to make sure that everything works properly. I think, it's sort of a renaissance of testing for cloud architectures now that infrastructure can be treated like software. Security is also a key component of that, where security is part, validation, making sure you're scanning and enforcing that you're not, making mistakes unknowingly, like, for example, opening ports to the internet that you didn't mean to, or S3 buckets that are unprotected. But also the practice of, the principle of least privilege, I think, is an important concept. It's always been an important concept, but I think now with the move to the cloud, the security perimeter has changed for applications. It's no longer the four walls of the data center, which is a physical perimeter. It's a virtual perimeter of the virtual private cloud that you're deploying into, and the firewall rules that protect and govern access to that, and the IAM roles and policies that you put in place. And so the idea of principle of least privilege is an application doesn't get granted access to perform an action unless it's opt-in and granted that privilege. And that's a real key to being able to move fast with confidence in this cloud engineering world.
Yeah, for sure. And when you think about the cloud as supercomputer and security not being an afterthought, like, we haven't really designed that least privilege stack all the way through the system, right? Like, when you think about your operating system's security model. It has this whole model ranging from, how do you get into the UI all the way down to, encrypted drives and BIOS boot security. And that chain doesn't exist across this massive supercomputer that we've created. So like we really do have to think about security not as an accidental side effect of what we've done, but it has to be this intentional design of what could be possible.
Yeah, and I love, when you think of the operating system analogy, it just becomes even more clear that security needs to be a fundamental part of how we develop this software. And I think, things, the job isn't done after you've done all of this verification and testing and you think you're ready to ship. Really, that's just the start of the game. That's just the beginning. Once it's out in production, now you need to monitor and react to what's going on. And so this is really up to each team to figure out how their own OODA loop. And what an OODA loop is kind of a term used by the U.S. Air Force for combat operations. Basically, the idea is, observing your surroundings, orienting yourself to your surroundings, deciding based on what you're observing, and then acting based on that. And I think that's a really good analogy to how we observe our cloud applications in the real world. And how do we figure out when something's wrong? How do we react to the unknown unknowns? And to do that properly really means that you're logging everything. You often can't know in advance what the important bits of data are going to be. The old model of just having very simple performance counters of CPU utilization in memory, for example. Yes, maybe you need those, but that's seldom the sort of information we need to really detect anomalies and react to them in modern cloud architectures, especially given how distributed they are in their nature.
Exactly, and if you can't see it, you can't orient yourself to it, right? Like if I can't observe my situation, that orientation step where I try to figure out, well, what am I going to do? Like given the inputs that I understand about what's happening, now I have to orient myself based on what I know about my mission, what I know about my surroundings, all of those things, so that I can make a good decision as quickly as possible about what the next action is. And these loops are really tight. And I think the big change here is going to be about being able to collect all of that data into an observability system that gives you that capacity to orient yourself quickly and to make better decisions about what to do next when things go wrong.
And I think the key thing is that all these things that we're talking about from a workflow perspective are all related. This is about how do we go from idea to actually shipping software in production that our end users are going to benefit from. And I think this is where continuous delivery comes in. Continuous delivery, this is not a new idea. We've been practicing this for, application delivery for a while now. Continuous integration is a sort of the idea of running the tests and running the acceptance testing before delivering. But really what we're seeing is moving from just application continuous delivery to also the infrastructure as well. As application development teams and infrastructure teams and the whole cloud engineering organization work closer together, really, this is how teams ship early and often. And this is how the whole team goes from shipping every quarter to shipping every month to shipping every week to daily. And many teams are trying to get to that nirvana of literally shipping features on every Git commit. Many people are able to do that. And that's because they're practicing continuous delivery and incorporating all of these cloud engineering or infrastructure software practices into their daily habits. And I think the exciting thing is that we're talking about applications and infrastructure, the developers and infrastructure engineers and DevOps teams working together on this. We're talking about all the validation. We talked about testing, security, before, during, and after, speaking to the observability importance there. And I think increasingly, we hear multi-cloud a lot. I think teams are really trying to centralize on cloud agnostic workflows that work for the team. The workflow is really for the team and has to empower the team to do their best work together and to be agile. And so that's a key element also.
Absolutely. I think when you focus in on the idea that continuous delivery is the workflow that gets our software and our infrastructure and all those things up into production, it's also one of the bellwethers that tells you that we have so much more to do in terms of thinking about the cloud as a supercomputer. Because when I want to deliver software on my computer, I don't like build a pipeline that then knows how to take my code from the editor to the running thing. Do you know what I mean? Not like that, I don't. And it's not that continuous delivery needs to go away, but the idea that what we're doing is continuously delivering the software, producing these artifacts, and then running them on the supercomputer, that needs to become the paradigm by which we see continuous delivery, as opposed to this process of building pipelines or sort of the how. Instead, it needs to be more about the what.
Talked about teams, and really workflow is about how the team works. So let's spend a minute just talking about how cloud engineering teams work. And really the thing I like to say is, cloud engineering is about taking, 1 + 1 = 3. It's about taking application developers and infrastructure teams and DevOps teams and having them work together to do more than they could have otherwise on their own. And, that speaks to the DevOps journey that we've been on and to the future, which is that cloud engineering teams are empowered. Everybody collaborates, contributing their own unique skills. Application developers focus on what they're great at. They're great at building applications and delivering functionality to end users. And increasingly now they're doing that with cloud capabilities, but really we want to empower developers to do what they're good at. And similarly, infrastructure teams and DevOps teams are great at engineering scalable, reliable, cost-effective foundations on top of which the entire organization runs. I like to say application developers, might not want to become experts in networking or how to build, scalable Kubernetes clusters that can scale across multiple regions. That's really in the infrastructure domain. And I think it's important that we recognize everybody brings passions and skills and things that they're good at to the table. And really cloud engineering is about empowering everybody to bring their best foot forward. And that includes security engineers also. Really, to the security is not an afterthought point. The way that we ensure it's not an afterthought is by making sure the security engineering team is a core part of the cloud engineering team as well. So that's sort of the architectures, workflows, and teams, kind of where we're at today. I think it'd be interesting just to spend a minute, looking into the future. We've alluded to a number of the key things that still need to happen, but I think it's pretty clear we're on the horizon of a lot of great breakthroughs in cloud engineering. I think, in fact, if I were to use a baseball analogy, we're still kind of in the third inning of the cloud. Whether that's because folks are still kind of moving from on-prem and hybrid into public cloud, people are still making the shift to, there's a lot of facets in which, we're still in the third inning. So a lot of excitement about the future, of course, and it all starts with cloud engineering. These are all foundational pieces. And in a sense, the future is really about just more of this. It's about really that operating system, the programming model, the application model really coming to fruition. So I think, super optimistic about the future. The good news, we're well on our way, and that cloud engineering is the foundation that's going to enable us all to get there. And so I want to thank you for coming to the talk today. I had a really exciting time telling the story. Thank you, Adam.
Thank you. So nice of you to let me hang out.
Anytime. Enjoy the summit. I hope you learned something today. I hope you learned something, a lot of things throughout the day. And we've got a lot of great talks here. And the talks are sort of organized to map back to the themes we talked about today here: architectures, workflows, and teams. So have an exciting time. Thanks again for coming. Thanks again for joining us.